Hi everyone, this is the video for objective number 2, factoring with common factors. So before we get into how do we actually factor, I want to just spend a moment talking about what is factoring. So you have been doing factoring, you've been identifying the factors of numbers likely for years in your math career. But when it comes to algebra, factoring is pretty much the reverse of expanding. So in the fall, when we did our expanding unit, we would have done a question like this, and we would have said, okay, expand this. So we would have said, all right, we got a number out in front of the brackets, we get some bracketed pieces, we're going to take that number and we're going to multiply it in to every term inside the brackets using distributive law. So that gives us 5x plus 10. So going this direction, from bracketed pieces to no bracketed pieces, that's called expanding. We've done that before. What we're doing in this unit is the reverse. So we're taking what would have been our answer in the fall and we're trying to figure out, okay, what did we multiply together to get that answer? And that is called factoring or factorization, depending on the source. So this is what we're doing. We're taking the answer and we're figuring out what did we multiply together to get us that. And we're going to look at 4 different ways of doing that. Depending on what kind of an expression it is that we're dealing with, you're going to factor it in a slightly different way. So what I want you to do before we even get started in examples for today is I want you to turn to a new piece of paper and I want you to create a flow chart. So we're going to add to this flow chart through every lesson in this unit. So this is going to be your guide, your go-to for how do I actually navigate all of the questions that we're going to do in this unit. So the title is going to be factoring. Every factoring question is going to start with an expression. So an expression that asks you to factor or factor fully or factorize or some sort of variation on that. And the first thing you're going to do always, see there's only one arrow, the first thing you're going to do is try to remove a greatest common factor. You will be able to in some questions, you will not be able to in some questions, but it has to be the first thing you try to do. So that's why it's going to take this first spot in our flow chart. We will come back and we'll do this example later, but I just want you to get this started. So by the end, we're going to have this whole page filled with examples and sort of tips and tricks and how to identify everything. But I want you to get that started now, and we're going to come back to that a little bit later. So first line of defense is factor by removing a greatest common factor. Okay, so what does that look like? So we're going to go through some examples here. So in the previous lesson, we would have looked at 3a and 6 individually, independently, and identify, do we have a greatest common factor? And so if you recall, you need to check numerically and you also need to check alphabetically. So if I look at these two terms, I know that the greatest common factor between them is going to be 3. If you cannot see that immediately, by all means, go to the margin, put a 3, put a 6, list out the factors of 3, list out the factors of 6, and you would eventually arrive at 3 being the greatest common factor. 6 does not have an alphabetical component, so there is going to be no variable component to our greatest common factor. So once you identify the greatest common factor and write that down, the next thing you're going to do is open a set of brackets. And you need to sort of think in reverse. What did I have to multiply 3 by in order to get 3a? The answer is I had to multiply 3 by a. And then you need to think to yourself, okay, what did I need to multiply 3 by in order to get 6? Positive 6. So keep that in mind. 3 times what gives me positive 6? The answer is positive 2. So that's how you factor. That's it. That's all there is to it. So the interesting thing about all of the questions in this unit is you could check them and determine whether or not you're right. So the check is do the distributive law, do the reverse, expand this and see if you get what you started with. So you would do 3 times a to give you the 3a, 3 times 2 to give you the 6. Okay, let's look at the next one. So 8x squared plus 12x. So first thing we're going to do is identify the greatest common factor. So if I look at 8 and 12, I know that the greatest common factor is 4. Again, if you cannot see that, make a little list. You need to get to the point where you can look at them and just identify what the greatest common factor is. But if you're not there yet, that's fine. Just make a list beside your question. So that's the numerical component. Then I look at the variable component. I've got an x squared and an x. So the greatest common factor there is going to be x. So the greatest common factor between 8x squared and 12x is 4x. Open a bracket, think in reverse. 4x times what gives me 8x squared? 4x times 2x gives me 8x squared. 4 times 2 gives me the 8. X times x gives me the x squared. 4x times what gives me 12x? 4x times positive 3 gives me 12x. So again, I can sort of work backward using the distributive law to arrive at the question that I started with. Let's move on. What happens if your first term is negative? And this is really important because this comes up a lot. If the first term is negative, no matter what, you are going to take out a negative as your common factor. So instantly, before you do the numerical component, before you do the variable, you know it's going to be negative, so put the negative there. Then I look numerically, 2 and 6, greatest common factor, 2. Then look alphabetically, variable, A, AB, A is my greatest common factor. Open a set of brackets. Negative 2A times what gives me negative 2A? Negative 2A times 1 gives me negative 2A. Negative 2A times what gives me positive 6AB? So negative times negative is going to give me the positive part. 2 times 3 is going to give me the 6. A times nothing is going to give me the A. And then I need a B to get the B. That was part of the original question. So again, you can check that by going negative 2A times 1 gives me negative 2A. Negative 2A times negative 3B, positive 6AB. Next one. What if both of them are negative? Doesn't matter. All you care about is if this first one is negative, then a negative is coming out as a greatest common factor. Then you go numerically. 2 and 4. Greatest common factor? 2. Variable, x squared and x. Greatest common factor is going to be x. Open a set of brackets. Negative 2x times what gives me negative 2x squared? Negative 2x times x gives me negative 2x squared. Then I need this second term to be negative. So negative times positive is going to give me the negative. 2 times 2 is going to give me the 4. And x times, I don't need anything else there to keep the x. So the final factored answer is going to be negative 2x, bracket, x plus 2. Okay, now we get into the more complicated looking ones, the ones that have brackets and have a little bit of extra stuff going on here. Don't be intimidated by them. So again, when we look at the greatest common factor of this first term and this second term, we're looking at what exists outside of the brackets. Do we have anything in common there? And we don't. And then we look at the bracketed piece. Do we have anything in common there? And we absolutely do. Those bracketed pieces are the same. So our greatest common factor is going to be x plus 3 in brackets. It's really crucially important. So open a set of brackets after your greatest common factor. And then you look at, what did I have to multiply this bracket by to get this entire piece? And the only thing that we didn't sort of deal with already is this 2. So that needs to get multiplied by this bracketed piece to end up with what we had here. And then what's left over from this second piece is just the x. So we look at what the symbol is there, and that's going to give us plus x. Close a bracket, we're done. So at first glance, these ones look more challenging, but they're actually a little bit easier because it's really obvious. You can see that those bracketed pieces are the same, pull that out as the common factor. You can see that those two pieces are left over, put them together in your second bracket. Okay, last example. So again, another bracketed question. So we look at outside of the brackets and we see that there's nothing outside of this bracket and there's a 3 there. So because it doesn't share anything in common here, there's nothing outside of the set of brackets. Then we look at bracketed pieces. We've got x minus 1 and an x minus 1. So that is going to be our common factor. So remember that these are divided by the positives and negatives. So you're looking at here and here in terms of what is in common. All right, so our x minus 1, that was in brackets, that's what our greatest common factor is. That has to stay in brackets because it was in brackets. Open a new set of brackets. We've already dealt with that one. So we have this remaining from our first term. So I'm going to put x plus 2, and I'm going to keep that in brackets. I probably should have made this square. I'm going to keep that in brackets for the moment. It's not going to matter so much in this question, but it will in others. And then we've already dealt with that. That was taken out as a common factor. So the only thing that's left over here is the 3. Math does not like brackets inside brackets. Math likes simple answers. The simpler we can make it, the more math likes it. So we can simplify inside that set of brackets. X plus 2 plus 3. We can look in here and see, do we have any like terms? And the answer is yes. We have a 2 and we have a 3, and those are like terms. So we're going to sort of simplify this a little bit. X plus 5. Okay, so those are some examples of what you're going to be doing in this objective. So I want you to flip back over to your flow chart, and we're going to finish off this example. So if we look at these two terms and we're asked to factor them, the greatest common factor, look numerically, is going to be 5. Look alphabetically, x squared and an x, that's going to be an x. Open a set of brackets, x squared times what gives me 5x squared? 5x times x. 5x times what gives me negative 25x? So negative 5. Okay, and that about does it for objective 2.